mitochondria. So what we are taught about the mitochondria is that it is the powerhouse of the cell. It produces ATP. ATP runs everything. Well, that's extremely myopic and inaccurate. So ATP doesn't actually produce all the energy of a cell. It does a lot of different things. And then, Gilbert Ling has proven that without a shadow of a doubt that ATP is not the sole producer of energy. And this is why we need to look at what else does the mitochondria do. Mitochondria actually produces water, right? Mitochondria produces CO2. Mitochondria produces melatonin. Mitochondria produce the base levels of heme proteins. Okay, so like the mitochondria is doing a lot of different things. The mitochondria also produce light, right? So this is where it gets really interesting when we're talking about this biophoton concept, is that the mitochondria is receiving light and it's emitting light, okay? And so every one of the complex has an emission and absorption spectrum. So the emission is what it releases, the absorption is what it receives. And so as we're looking at that, complex 1 is UV range, and then we can start going into complex 4, which is, or complex cytochrome C, which is going to be infrared. And so the other aspect of this, without getting too technical, where ATP is produced is a tiny quantum machine. This is spinning. It's a rotating head that spins off ATP. It takes a DP, turns it into ATP along with the electron transport chain. Now, when it is exposed to red light, it runs at 100% efficiency. Okay? 100% efficiency. This is a magical little quantum motor that we have in all the mitochondria. When you think about the trillions of mitochondria we have, fascinating, right? So if light is affecting every one of these components of the mitochondria in the production of what they do, it would stand to reason that's an extremely important aspect of what's